What's going on, programmers? So in this video, I want to walk you through the Bluebook testing environment to show you what tools you have at your disposal in this environment. And I think the best way to demonstrate this is to actually go through the practice exam through Bluebook. So this is the AP ComSci A practice exam. And we're going to start off with the multiple choice section, and then I'll do an FRQ question to show you like what if I was to take this test, how exactly would I navigate in this environment? So first off, let's start at the very top. We've got a timer here. This is going to be ticking down. If you're one that have test anxiety and you think that this timer is going to negatively affect you, go ahead and just hide that, okay? And just do your best and answer all the questions you can. You may want to occasionally check to see how much time you have left, because say you have only a couple minutes left, but you got 5 questions left to do, you might as well just throw up some Hail Marys and answer some questions, okay? So occasionally check in on this time if you hide it, but I would definitely say turn it off if you think it's going to give you more test anxiety. Now, over here, we have this reference sheet. This is the reference sheet that we've been using all year during our assessments. And we have our string class here. You'll be able to go back and forth, but if you want a wider view, now on my view here, because I have a pretty large screen, I don't have to scroll back and forth here because everything it's already here. But for some of your screens that might be a little bit smaller, you're going to want to expand it so that you can see the method header and then the explanation of the method in here, right? And when you close it, if you open it up like this, when you close it and you go to open it back up, it'll already be here, so you don't have to keep expanding it or whatever. Just go ahead and close that thing there. Now, notice when you click on this notes and highlights, there's nothing happening here. So how this actually works is you're going to go to your questions, and anywhere in here you can just highlight, and then you could select which color you want to highlight it, if you want to underline it, or if you wanted to add a note, okay? So there's that, and then we can remove this by just hitting that delete button there. And then say you wanted to add a note, you can just delete that note as well, just like this, okay? Oops, delete. Now, here at the very bottom, you'll see all the questions here, and you see how it's like you got this like dotted line and there's no color or anything. This can tell you which questions are unanswered. Now, hopefully you're going through the exam and you're not leaving stuff unanswered. What I hope that you're doing is that you're marking them for review. So notice when I go down here, you see this little red flag right here. This tells us that this question, you flagged it, you might want to review it. Now, I would highly suggest that if you flag something, do answer the question just in case you don't have time to get back to it, okay? But when you do answer the question, notice it gets filled in. So I would rather have you have these filled in with a flag. That way you at least have an answer on there, if anything, okay? There's another button right here, and you're gonna want this ability to rule out answers. So notice when I click that little letter with the slash going through it, like the slash going through the bubble, this is how we can rule out possible answers. And this is going to be super powerful, especially if we have to skip a question and come back to it. So if we flag it and we're going to come back to it later, if we rule out some answers, then we can think a little bit more about the 1 in 3 or the 1 in 3 or 1 in 2 answers that we need to consider. That'll save you a little bit of time. So that's super powerful there. And then, yeah, other than that, let's go ahead, let's get started with this first problem. So this first problem says, hey, consider this following code segment. We have some variables that we're creating. We're creating some other variables using those variables that we just created, and then we're printing these 2 variables. Now, first thing that you want to notice is that we're printing X and Y. X and Y are being created using Q and R, okay? Now, these are both doubles here, and notice this one's a double and this is an int. Okay, so take note of the data types. The fact that we're printing 2 doubles, if any of these answers had integer values that were being displayed, then we could easily rule that out, right? So let's start with this first one. So X is going to be the casting of Q divided by R. Now this Q divided by R is going to occur first. So if we do 15.0 divided by 2, we're going to get 7.5. So we're going to get 7.5 here, but when we cast it to an int, we're going to get 7. That's going to then get stored into x, but x is a double, so we're going to end up with 7.0. Now, luckily, all of these were already doubles, but sometimes they'll throw in a curveball where 7 is one of the answers. If 7 was one of the answers, you'd want to rule that out because the data type is a double. But sometimes they'll have it in here, but they don't have that trick in here. But the fact that we're getting 7.0 stored here, we can already rule C out because the x value is not going to be 7.5. So these two answers we can rule out because of those things here. Notice how I highlighted them. So if I wanted to flag this and come back to it, at least I can know why I'm ruling those out. So using the highlighter even on the solutions could help you if you're going to go back and review. That way you can be like, okay, why exactly was I ruling it out? And this highlighting can help you more easily identify why you ruled it out. So then it boils down to the y value. So if we take Q is 15.0, R is 2. Now this is a double divided by an int. The result is going to be a double, and it's going to work out how we expect. So it would be one thing if these were both integers, then we'd have to worry about integer division. But for here, 15.0 divided by 2, we're going to end up with 7.5. Notice the only difference between this one is this is 7.0, this is 7.5, but this is in fact the right answer. And the reason why we're going with that one is because there's 7.0 here. Okay, so let's move on to the next question. Now we have another thing. Consider the following code segment. We've got X is being assigned some, looks like it's being a random number here, and then Y is being a random number, and then we're printing X or Y. And they're asking, hey, which of the following could be printed? Could be printed. Because we're using math.random here, it's going to generate a random number. So what we have to do is we're going to have to think about what are the possible values that X can be, what are the possible values that Y can be, and then once we determine the range of values, then we can figure out which one of these answers fits those ranges, okay? So let's start off with this one. Math.random times 10. This here is going to give us a random number between 0 to 9.999999, right? Then this piece here is going to get casted as an int. So then what we get is it's going to go from 0 to 9. And then when we add 5 here, X is going to be some number between 5 and 14. So we know that X is going to be somewhere between 5 and 14. So if there's anything less than 5, anything greater than 14 for the first value, we can automatically rule out. So notice, answer D, we can automatically rule this one out because it's outside of that range. Now, unfortunately, 10, 9, and 8, those are all in this range of 5 to 14. So now what we have to do is we have to consider the Y piece. So what we can do here is we can do the same thing. I can say, oh, okay, this piece right here is going to give me a number between 0 and 4.99999. So then when I cast it as an int, we're going to get a number between 0 and 4. And then when we add 10, we then see that we're going to get something between 10 and 14 because we're just adding 10 to the possible values here, right? So our Y value is going to be something between 10 and 14. Well, because this is 15 here, and that's outside of the range, we can rule this out. This 12 is between 10 and 14. This 7 here is outside of that range. So we know we can go with this one. All right. So let's go to our next problem. So we have this date class. A date is something that has two instance variables, one being a string, one being an int. there's a constructor here that takes in a string and an int, and there's nothing else being shown here. So it says, which of the following code segments appearing in a class other than date will correctly create an instance of a date object? So first thing to note, the declaration for this birthday variable, it's working for all of these, okay? Now, this is where you want to be very, very careful and make sure you're paying attention to the class here. We only have one constructor here. The fact that there's no other, you can't assume that there's other constructors or anything like that. If there's no constructors in the class, you know that the empty parameter constructor exists, which is coming from the objects class. But the moment that we have a constructor, that is the only constructor that exists. So the fact that this one has only one value being passed to it, we only have one constructor which takes in two parameters. So we can rule this one out and we can rule this one out simply because of the one parameter constructor and the zero parameter constructor that are being called here. That's what's screaming at me that these don't work. This other one also doesn't work for some other reasons, but that's the first thing that is screaming at me. The answer D also doesn't work because notice these instance variables are private. You can't even access them like this. So this doesn't work as well. So then notice this one here. We also have a 2 parameter and a 2 parameter here, but this is a string and an int being passed. This is a string and a string. So the fact that our constructor takes in a string and an int, that matches up with this one here, but not this. This is a red flag here, so we can rule this one out because of that. So this is going to be our answer. Now it says, consider the following code segment. So we have str1 is being initialized to be the string literal. Now str2 is being initialized to be a substring of this. So remember, this is the 0. So we're using substring 3, meaning we're starting at index 3 and finishing that thing off. So 0, 1, 2. So we're starting at index 3 and finishing that thing off. So this right here, OP, is exactly what str2 is. So I can take this and say, oh, this is OP. So then str2 then becomes, or str2, what we're going to do is we're going to add on, and when we plus equal on a string, we're just adding it to the very end. Now let's see what this str1, substring 2, 3, let's see what this is. So 0, 1, 2. Now when we use the 2 parameter substring method, we say start at this index, go up to not including this index. So 0, 1, 2, we're going to start at index 2 and go up to not including index 3. So that means we're not going to include the O here. So this is going to simply just be the N. So then what we end up with is, for this here, we have our OP already, and we're going to add at the very end this substring 2, 3. So we want to look for an answer that looks like this. Okay? So bang, there's our answer. Now, notice that I didn't really go through and rule anything out on here, but sometimes just walking through the algorithm here and then seeing if you have an answer that matches your answer. If you find the matching thing 9 times out of 10, you're right. Okay? But the one problem with that is, like the 1 out of 10 times, is that there could be a common misconception that students have, whether it's stopping too early, ending too early. So this is where you're going to have to be a little bit more careful and maybe flag this one if you didn't rule things out or figure out why you're ruling things out. But here, sometimes it just works out nicely for us. I think this one's not too difficult. So we can just move on from here. All right, so this next one, we have the following method is intended to return the string Renaissance for years from 1400 to 1600 inclusive, medieval for years 400 to 1399, or other for any other year. So we have this method called getCategory. Notice that it's returning a string, so it's going to return one of these strings for some, depending on what year is being passed to here. So we're initializing category to be an empty string, and then we're returning it at the very end. So what we have here in this missing code is we're going to need some type of conditional structure to assign category to the appropriate value. Now, since we have three possibilities here, and it could either be this, that, or the other, we're going to make sure that we're using an else if structure here. We don't want to necessarily be using an if. So looking at the possible answers here, I would be inclined to rule out this one and this one, because this is an else if structure, and then this one's an else if structure. Those two there are else if structures. Now, it could be that neither one of those work, but I would start by checking those two first, and then if those don't work, maybe look at the other two, because there could be some funky things going on with them. But let's start off with this first one. Let's see. So if year is greater than 1600 or less than 400, that means you guys are going to be given scratch paper. It might be useful for something like this if you were to draw like a number line and see what this statement is saying. So this is saying the right part of 1600 and less than 400. So that means the out of bounds stuff, meaning we're supposed to be getting things from 400 to 1600 here for medieval and Renaissance. Other should be everything greater than or less than 400. So far that looks like it works. Else if year is greater than or equal to 1400. So if we're not out of bounds and we are greater than or equal to 1400, the fact that we're not here or not here, but we're greater than or equal to 1400, this is going to give us that 1400 to 1600 here. And then if we're greater than or equal to 400, so this one looks like it works, but let's just check this one in case, just in case. So this is saying, hey, if the year is greater than or equal to 1400, Renaissance. Now, a lot of students might jump here because they see this one is greater than or equal to 14, and then other. This is basically saying from 1400 all the way forward. So the reason why this one doesn't quite work is because of this category here, because we can have something that is, let's say 1700. 1700 should not be Renaissance. It should be other, right? So this is also including that. So you got to be very, very careful here. So this looks like the answer that we want to go with, okay? We can go through why these ones also, this one doesn't work and this one doesn't work, but you got to be careful with this if. With these ifs here, it could change, like you could set it to other and then it could change to Renaissance. Like for example, if it was 1700, 1700 would end up being other, Renaissance, and then it would be also medieval because it's going to execute each of these. So that's why it wouldn't work. But let's move on to the next one. All right, assuming that X, Y, and Z are Boolean variables that have been properly declared and initialized, which of the following expressions is equivalent to this one? So we want an expression here that's going to be equivalent to this. Now, you could look at this and be like, oh, I could reverse De Morgan law of this. I think it's a little bit easier to look at your possible answers and then apply De Morgan's law to these and then compare it. So let's look at this first one. Not X and Y is equivalent to not X or not Y. So we'll have not X or not Y, and then we'd also have and Z. So this and here is what's killing us from matching up with this here. So we can rule that one out because of that. So this is again going to be that same not X or not Y or Z. That matches up exactly, but let's check these other ones just in case. Now, if I look at this one here, not X or Y is going to be equivalent to not X and not Y. Now that is very different from this. This is an and, this is an or. So for that reason, we can rule this one out and we can rule this one out, right? So these two could automatically be ruled out because not X or Y is equivalent to not X and not Y, which is not the same as this piece here. So those probably could have been the first two that we ruled out here. All right. Consider the following code segment. So it looks like we've got two for loops here. We're printing some value, and then we're jumping to a new line. So the code segment is intended to produce this output here. Which of the following can be used to replace missing code so that this code segment works as intended? Now, we're trying to plug something in here. We're going to be printing K. So this is J up here. We're printing K. So the value that we're going to be printing each row, on each row, it needs to always start off at 0. So the fact that it needs to always start off at 0, looking at our possible answers here, we can rule out this and this because our J value is going to be, our J value here is going to be varying. And yes, on the first iteration, it's going to be 0, but on the next iteration, it's going to be 3 because we're counting down. We're going from 4 down, right? So now these two, we start at 0, incrementing K. The only difference between these two is less than and less than are equal to. So we're printing K. And on the first row, K is supposed to be 0, 1, 2, 3. We're not going to print 4. So J is going to start off at 4. So because J is starting off at 4, we're not going to want this less than or equal to here. We're going to want to be strictly less than. So this is why we're ruling this one out, is because this less than or equal to piece. All right, I'm going to do a few more. We'll do 8, 9, 10, and then we'll do some FRQs. So consider the following code segment. We have this code segment here, and it says, how many times will the statement in line 6 be executed as a result of running this code segment? So we start J at 1, and we're going to keep going as long as J is less than 4. So that means that J is going to equal, so this piece here, we can see because we're between that and this here, and we're not incrementing J anywhere else, we know that J is going to be 1, 2, and 3. When J becomes 4, we're not going to go inside here anymore. So we know that J is going to be 1, 2, and 3. And then we've got K starts out at 0 as long as it is less than or equal to 4. So this piece here, the fact that we're starting at 0 and K is less than or equal to 4, this means that K is going to be 0, 1, 2, 3, and 4. So that means we're going to do this outer loop 3 times. And then each time we do that, we're going to do this inner loop 5 times. So we've got 3 times 5, that's going to be 15 for this. Okay, next one. We've got a programmer is creating a movie class that will contain attributes for a movie's title and its average rating on a scale from 0.0 to 5.0. The class must also contain methods that allow attributes to be accessed outside of the class. A class diagram for the movie class is, contains 3 sections. The first section contains the class name. The second section contains the 2 instance variables and their data types. And the third section contains the 2 methods and the return types. The plus symbol indicates public. The minus symbol indicates private. So we've got this little diagram here of this is like this diagram is supposed to represent a class and what the class is supposed to have, and then the privacy, the access modifiers, which are being designated by the plus or minus. Okay, so all of these are movie. We should have 2 instance variables, 2 attributes, instance variables, where one's the title and one is the average rating, and it looks like it's a decimal number. So we should have a string and a double. So the fact that this one here is, oh, I can't highlight it, but this int here, I think it's because this is probably an image. You may not be able to highlight some of the stuff. So the fact that this is an int here, I can rule this one out. The fact that I have an int here, I can rule this one out. So then string double, string double. Now, the difference between these is the only difference between these is that I've got plus plus minus minus and minus minus plus plus. So the plus is supposed to mean public, the minus is supposed to be private. Remember, when we're designing our classes, best practices is that we make our instance variables private and our methods public. That's how we get access to our private instance variables. So this right here is indicating that we have public instance variables and private methods. This one is private instance variables, public methods. So this is going to be the correct answer. So then we have a programmer developed a method and wants to allow other programmers to use their method in other programs without raising intellectual property concerns. Which of the following actions is most likely to support this goal? Designating the method as public, maybe. Designating the method as static in a method header, maybe. Publishing the code for the method as open source. Okay, that sounds like we're allowing we're enabling others to be able to use it. And then removing all personal information from the data. So this probably makes the least amount of sense. Sometimes with these answers, I can see why somebody might think this here, putting public in the method header. Yes, we'll have access to that method outside of the class, but making the method public doesn't guarantee that you're going to have access to the method, because it could be that the class is declared as private. So if it's private, then you're not going to have access to the method. So like there's some funky situations here with this answer. Being static just means that we don't need an instance of the class to call on the method. But we could still have the method. If we have a private static method, you can't call on it. So it could be that it's still private. So this is why I would probably rule this one out. But this is the answer that makes the most sense. That if we have some code and we don't want to worry about these intellectual property concerns, we post it as an open source, meaning we're providing permission for others to scrape that code, to fork it and use it elsewhere. So this is probably the best answer for that situation. So this is the multiple choice section. We'll go to the FRQ. Hopefully you found this part valuable, and you don't have to use the tips and tricks. Like, I'm just showing you how I might do this. What's going to be important is that you go through this, use this practice assessment, and figure out what things work best for you, what makes most sense to you, what are you most comfortable with. But you definitely want to practice with this. That way you could save yourself some time and be a little bit more organized with your thoughts. It's already going to be hard enough with the anxiety and everything going on. Being able to be a little bit more organized, and having these tools at your disposal, knowing how to use them, where everything is, that's going to be super clutch. Okay, so hopefully you found that part valuable. All right, so we're finishing up the multiple choice section now. So if we keep going, we finished it. Now on the exam day, you're gonna have, I believe it's a 10 or 15-minute break in between the two parts. Okay, you're going to make sure you take that time, unwind, because I think the second part, the FRQ section, you're going to want to be a lot more careful with this. There's going to be a lot more reading comprehension that's going to be necessary for this. So you're going to make sure that you're in the right mindset going in. So let's dive right in now. So here's section 2. All right. So what's probably most important about this section is you take your time reading and interpreting the problems. If you skim through, you're going to have to keep referring back, and you're going to waste a lot of time if you're just skimming through, trying to do something and then having to skim again. Just go through, even if you have to spend 7-8 minutes, reading through the prompt slowly, and then you only have 14 minutes to type out your solution. You're going to do so much better if you know what you're doing, and you're going to increase your chances of scoring higher. You're going to maximize your score if you actually answer the prompt and not answer your interpretation of the prompt, if that makes sense. Like, you want to make sure you answer exactly what's being asked of you. And a lot of the times they're going to drop gems. So I'm going to go through and I'm going to read this slowly with you. And I'm going to show you kind of how I would analyze everything, maybe take notes, highlight, things like that. And then we'll start typing out the solution. So this question involves the message builder class, which is used to generate a message based on a starting word. The message builder class contains a helper method, get next word. So notice there's a helper method. Anytime they say something about helper methods, 9 times out of 10, you're going to use the helper method somewhere. So just put that in your head that you're probably going to have to call on this method. 9 times out of 10, you're going to have to call on this method in one of your parts or in your code somewhere. So you will write a constructor and a method. So this is a 2-part problem. We're going to write a constructor and a method in the message builder class. So here is our class. Notice that we've got 2 instance variables. One is a string, one is a integer, and then we have our constructor here. Now, remember that the primary purpose of a constructor is to initialize your instance variable. So we're going to have to initialize these to be something. So already have that in your head that if we're going to have to write this constructor here, we're going to have to do something with these instance variables, okay? So what does this constructor do? It builds a message starting with the word specified by the parameter and counts the number of words in the message as described in part A. So there's a description down here. We'll read that in a little bit. I can't emphasize enough the preconditions and postconditions. Don't just think of them as extra information that's unnecessary, that it's just there for no reason. This can be a huge lifesaver if you read the preconditions and the postconditions, because they'll let you know what you can assume about the problem. Okay, so starting word, the thing that we're passing in, we're going to assume that it's a single word with no spaces. Okay, so this is always going to be a single word with no spaces. So that's what we're going to be able to assume with this. So we have another method here called get next word. This method returns a string and it passes in a string. So what does it do? It returns a word to follow the word specified by the parameter, or null if there are no remaining words. So the precondition is that S is a single word with no spaces. The postcondition is that it returns an individual word with no spaces. Notice the implementation is not shown. All we know is that we pass in some string and then a string is output. Now the string that's being output is either going to be null or the word that's supposed to come after the word that we pass in. So we have this variable message here. They do a pretty good job with the naming convention of their variables on the FRQ section, okay? So the fact that we have message here, you can kind of assume that it's going to be a multi-word string. You know what I'm saying? So we'll see how this all works together shortly. Let me just, I'm going to skip part B for right now. But we have our one helper method. There's no other methods. We can't assume any other constructors or methods that exist. Now, okay, so the following information applies to part A. In part A, you will write the constructor, which uses a helper. It uses a helper method. Uses a helper method. There's only one helper method in there, okay? So the fact that we're saying uses the helper method, you know in the constructor you're going to have to call on your get next word method, okay? To create a message starting with the word specified by the parameter starting word and assigns the message to the instance variable message. The constructor also counts the number of words in the message and assigns the count to the instance variable num words. So just from reading that part, message, we're going to be constructing it inside the constructor, and num words, we're going to have to do probably some type of incrementation as we're constructing our message. All right. Each word in the message will be separated by a single space. This is probably something that you're going to highlight. Separated by each word, separated by a single space. That's going to be important. A helper method, get next word, has been provided to obtain words to be added to the message. Each call to get next word returns the next word in the message based on the word most recently added to the message. When there are no more words to be added to the message, get next word returns null. Consecutive calls to get next word are guaranteed to eventually, so this is important, consecutive calls to get next word are guaranteed to eventually return null. So here's an example. Consider the following calls to get next word, which are made within the message builder class. And then this returns the value of each call is used in the next call. So we start off by calling to this method, passing in this value, and then book gets returned. So then we pass book to the method, on gets returned. Pass that to the method, the gets returned. And then the gets passed, table gets returned. Table gets passed, oh snaps, notice this is no longer a string, this is null here. So based on these return values, a call to the message builder constructor with an argument the should return the instance variable message to, so message is going to look like the book on the table. And the num word should be set to 5. Here's another example. We pass in good, morning gets returned. Pass in morning, sunshine gets returned. Pass in sunshine, null gets returned. So then based on these return values, a call to the message builder constructor with arguments good should set up our instance variable message to be good morning sunshine with num words equaling 3. Okay, so let's do part A and then we'll do part B. Now you could, if you want, read through part B, but I think if you take this one chunk at a time, it makes it a little bit easier to go through. So we're gonna complete this constructor. Okay. Remember, the whole purpose of our constructor is to initialize the instance variable. So we know we're gonna have to do something with message, and we're gonna have to do something with num words. So you should be thinking, okay, I have to at least start here. Message and num words, I'm gonna initialize them to be something. Now, this constructor is a bit more dynamic than probably some of the constructors we've dealt with through the course this year, because we are not just initializing them to be the parameters that we pass in. Based on the parameter that's passed in is going to dictate how these things are constructed. Now, we know that we're going to have to call on, notice, I should have read this part too. You must use get next word. So we're going to have to use this method somewhere in our constructor as well. So if just writing this stuff down, we're already brainstorming the pieces that we need to this puzzle. Okay. Now get next word. This method is not an empty parameter method. It should take in a value. So we're probably going to want to pass in, well, this method takes in a string. There's no other strings that are around here. So we're going to probably pass in our starting word, and then this is going to return something. So let's start message to equal an empty string. And num words, message, let's start message to be starting word. And the reason why I'm starting message to be with starting word, because we know that our starting word, so in our examples here, the was the first word. So message started with the. When we add this here, num words is now equal to 1. Okay? Now when we call to this method here, it's going to return a word, and the word that's being returned is going to be the next word. Now, if we just call this and don't store it anywhere or do anything with it, um, it just, this is just going to execute, but nothing is going to happen. Like this, the next word is going to be returned, but then we forget about what was just returned. So let's go ahead and let's assign this to a variable. And this is going to be the next word. Now, get next word is a non-void method, meaning it returns something. What exactly does it return? Well, it returns a string. So make sure that the data type that you use for the variable here, it matches up. So first step, message is going to be the first word. Numword starts off at 1 because we've already added a word to it. So once we get the next word is either going to store the next word or it's going to store null. So we're going to have to do something where we're checking if next word is null. But we're going to want to keep going through this process over and over and over until we get a null. So this is going to prompt us to use a loop here, more specifically a while loop. So while next word does not equal null, what is it that we want to do? So notice I did my while, I put my condition in here, I put my open close brackets here. Now this works where we can tab, and please indent your code, make it a lot easier on the graders. They're probably going to be a lot more, when you make it their job easier to grade your prompt, they're probably less likely to make mistakes in the grading process. So be kind to the graders. Make sure that you write your code cleanly, okay? So while next word does not equal null, what we're going to want to do is we're going to want to take message and we're going to want to add on to the end of it next word. But if we just add next word to the end of it, everything's going to be like mushed up on top of one another. So before we add the next word, we're going to need a space character along with it. So we want that space character along with next word. And then what we're going to do is we're going to reassign next word to equal, take this, utilize the beauty of coding, copy and paste. But instead of passing in starting word, we're going to want it to be next word. Okay? So we added this on here. Oh, let me take a step back. When we add a word on here, we should also increment the number of words that we have in our thing. All right. So now that we've created our first word and we've stored it in there, we've gotten the next word. We've checked if next word is null or not. If it's not null, we'll just add in a space with next word. Numwords gets incremented. Then we get our next word. Next word is going to be another string, or it's going to be null. So whenever it goes back up, we're going to check if it's storing null. If it's storing null, then it's going to not add it, and then we're done. Okay? So this is going to take care of the updating of message and num words, and they're going to be the appropriate values. Okay? So now we are done with this solution. So we should be good with this now. Let's go ahead and move on to part B. So we've completed this here. This is part A. Notice down here we've got 1A, 1B, 2, 3, 4. So this is a two-part problem. So we could go over to the next one. Since we've typed some stuff in here, this is here. Now, if you weren't quite complete, like if you didn't quite complete this, you could always flag it, okay? And then also remember that we have our reference thing here. Same thing applies. if say we needed to use some of these string methods or something, because we are dealing with strings here, say you wanted to reference these to see if any of these things might help you, you could do so. All right, so let's go ahead and go on to the next one, but I feel pretty good about that one. All right, so looks like the same exact prompt. Oh, that's super dope. So everything that we've highlighted and everything, because this is part A and part B, let me go to 2 real quick. Yeah, because this is part A and part B, all of our annotations, they stuck. Oh, that's awesome. So all of our annotations and everything are still here. So what are we doing in part B? So we have this method called get abbreviation. So what does this method do? It returns an abbreviation for the instance variable message as described in part B. So we're going to get our description down there. The precondition: each word in message is separated by a single space. So we're guaranteed that each word is separated by a single space, and that we contain 2 or more words. So this is actually very helpful. We don't have to think too hard. They actually make it a little bit easier on us. We don't have to take some of these edge cases into consideration. And then the post condition is that message is unchanged. Okay, so we got to make sure that we're not, this is very, very important. We got to make sure that message is not changed when we do this. Okay. So part B, let's read up on this. So in part B, you will write this method, which returns an abbreviation consisting of the first letters of each word. So this is abbreviation consisting of the first letters of each word in message. First letters, you might want to highlight that. Assume that message consists of 2 or more words. So another assumption here, and that we have spaces in between every word. So for example, if the message is as soon as possible, then get abbreviation should return ASAP. All right. So we got to complete this method here. Let's start off by, if we're writing methods, okay, especially if we're writing non-void methods, this is the first thing that you should be doing when you go to write your solution. Make note of the fact that this is a non-void method. We know that this method returns a string. So let's go ahead, let's create a string variable. Let's just call it result, and let's set it to the empty string. And then at the very end, we will return result. Doing this little step here, sometimes just doing this step is worth a point. So not only that, it allows us to not get lost in the sauce, right? So what is it we're trying to do? We're trying to construct some string and then return it. So now we have to go through and figure out how exactly we're going to construct this string. Well, this string is going to be the first letter of every word in our message. Okay? Now we know that every single word and message is separated by a space. So I'm going to actually show you guys a few ways that we could have gone about this. Now, we have our reference guide here. We have our string class here. We're definitely going to want to use our substring method, especially the 2 parameter one, not the 1 parameter one. We're going to want to use this 2 parameter substring method. We might want to use this index of. We could possibly use this split method as well. So let me show you guys how I might go about it. And then I'll show you some other ways of possibly thinking about this. But I think what makes the most sense, especially this year, since we added this method to the curriculum, the split method, it is super awesome, especially for something like this, where we know that we're gonna have a string, and every single string in message, like every time for every message string, it's gonna be words separated by a space. That could be beautiful here if we use this. So let me go ahead and do that. So I'm gonna create a string array. Let me just call this AR. And I'm going to assign this to be message.split. And I'm going to put a space character in here. So what this is going to do is it's going to create a string array where every element in that string array is going to be every word in the array. So this makes our job so much easier because now I just need to grab the elements of the array one at a time, grab the first character, and then add it to result. So we just got to iterate through. Start at 0 as long as I is less than arr.length. And then what we're going to do is let's add to result the ith element, the first character, which is the character at the 0th position going up to not including 1. We're going to set result equal to this character. Now this is where we got to be careful, okay? We're iterating through. We're grabbing this character. We don't want result to equal this. We want to just add it to the end. So each element in here, we're good, okay? So this is one way that we could go about solving this, okay? So you might be thinking, okay, what if I didn't think to use that split method, okay? Then maybe another intuitive way is to just iterate. So we'll take result and we'll set it equal to message dot substring 0, 1. This will make result have that first character in there. And then let's create a variable idx that is going to be tracking where is the space character in message, right? So message dot index of, or I'm sorry. Let me take a step back. I'm combining two different ways that we could have gone about it. I'll do that in a second. Okay, so what might be another intuitive way is you get that 0th character, right? And then let's just say we just start iterating from that point forward. If I just iterate through the string, so int I equals 0, as long as I equals 0, as long as I is less than message.length. Let's say I just want to iterate through the string. And what we're going to do is we're going to now, actually, since we already did the 0th character, it's not going to make a difference in our solution, but we've already got this. Let's start at index 1. This makes more sense. What we're going to do is we're going to check if, or actually, let's string char equals message dot substring I comma I plus 1. So we're grabbing the character of the position that we're at. If that character is equal to a space character, what we will do is we will take result and we will add on a substring, but this is where it's going to be a little bit funkier. So the ith position is where we have a space. So the I plus 1th position is going to be that first character, and then we're going to want to go up to one more than that, so we're going to have I plus 2. Okay? So this also works. It's going to increment, it'll go through, and then since we're guaranteed that we're going to have word space, word space, word space, and then it's going to end with a word at the very end, we don't have to worry about an index out of bounds situation because there's not going to be a space character at the very, very end. So we can assume with these preconditions that situation there, okay? So that's another way that we could have gone about this. Another way of maybe going about this is Notice that we said that message cannot be changed. Message must be unchanged. So this is a common trick. Let's just call this temp. And we're going to assign temp to be whatever message currently is. And then we're going to int idx equals temp.index of our space character. Okay? And what we're going to do is while idx is greater than or equal to 0, or maybe better said is not equal to -1, meaning while we have a space character in here, we can take result and add on a substring of message, or I'm sorry, a substring of temp, because you'll see why I'm setting temp equal to message here. When we give me a second to just do this piece real quick, and then we'll go back to it. So I'm going to set result equal to the IDX plus 1th position, IDX plus 2, because the IDX position is where we have a space character. So I'm going to do this, and then I'm going to take temp and set it equal to temp.substring IDX plus 2. And then we're going to reset IDX again to be where the next index is. So what this is going to do is, let's say, I think the best way to demonstrate this is let's use the example that we have right here. So, oops, I can't. Okay, let's just the book on the table. So, message is storing this. Our result starts off being T. Temp starts off being exactly what this is. So if you still have time, this might be a good practice for you, is you will like kind of work through it either on paper or maybe in the environment here to make sure that this actually works as you intend. So IDX equals, it's going to start off by equaling, so here's the 0, 1, 2, 3. So IDX is going to start off at being 3. So result, let me actually change this so that we're in the same exact order. So message is currently storing this. Result gets T, then temp gets whatever message is storing, which is this. And then IDX is going to equal 3 because that's where the space character is. So then, because IDX is not equal to -1, we're going to go inside here, and result is going to be given the 4th up to not including the 5th position. So 0, 1, 2, 3, 4. So it's going to be B. And then temp is going to end up equaling 3 plus 2 is 5. So that's 0, 1, 2, 3, 4, 5. I'm sorry. Yeah, so that's where we messed up here. So now temp should be IDX plus 1. I'm tripping. We would be in the middle of the thing and this would still work out. But so this should be 4 here. So 0, 1, 2, 3, 4. This is what now temp should be. So we wanted to go one more than where the space character currently was. So then IDX then becomes, it's no longer 3, it's going to be 0, 1, 2, 3, 4. So now IDX is going to equal 4. We go back up. It's no longer -1. So do you guys see how this is going to work now? So using this little example here is could be super beneficial. I don't know if you would lose the point for this part because technically you'd be cutting off. There could have been an issue if you only had like a 1-letter word or 2-letter word. Then it could have been problematic there. But yeah, you'd probably lose 1 point on there. But that's where doing an example and walking through it can be very beneficial. But this is probably, I'm just showing you different solutions to this problem. Like I said, the first example that I did is probably how I would have thought about it. And then probably the second solution I showed you would have probably been my second go-to. This is just another way of like this idea of chopping the string down. And the reason why we have to create this temp variable, we have to have this temp variable because this post condition here. Okay, so if you did this solution and you used message instead of temp and you kept chopping it down, you'd probably lose a point for that. So that's where you got to be careful and make sure that you're not changing things that shouldn't be changed. Okay, so just creating some temporary variable allows us to do that because remember, this is a reference type. So whenever I set it equal to message, it references that same thing, but then when I reassign it something new, it doesn't change that object that message is referring to. Okay, so this is the FRQ section. I'm not going to do any more of the problems, but hopefully you found some value in this. And if, like I said, the best thing to do with these FRQs is you want to expose yourself to as many of these as you can. And if you're struggling through them, it's okay. Utilize AI to help you think of the solutions or whatever, or brainstorm with AI to see if your thought process works, if the way that you're thinking would result in a solution that works, or what holes you might have in your solution. That'll get you closer and closer to like a better understanding or better strategies for these problems. There is no one size fit all. Yes, we have our, problem 1 is going to be, methods and control structures. Problem 2 is going to be classes, and then, array lists and 2D arrays. Yes, but there's so many variations of questions that can be thrown at you. The best way to go about this, try all the FRQs you possibly can, and go through the solutions, make sure that they make sense to you, figure out what strategies make sense in your head, and understand that there are multiple ways that you guys can approach these. So don't think about the most efficient, just go with what makes most sense in your head, because if you're trying to think of the most, efficient code, you're going to run out of time, or you're going to make some silly errors because you're making it so much more difficult on yourselves. So thank you for watching, and stay tuned for more content like this.